Hello. Yeah, I don't know. You can leave it like this, or you can just combine everything, have one return. I feel like combining it, but I'm doubting that it is now really making things more clear. Which probably isn't. Just making things more compact. I'm gonna go for the compact thing. So if samples equals either is on equal samples begin, and if either equals samples begin, then either -1 doesn't exist. So then it's not close. We just use either. Which is begin, then the first one. So if either equals begin, then we use either sample. If either equals begin, then we don't do this and we just use either sample. So that takes care of this one. And in this case, it can also not be equal to end, because then we cannot do this. So if either equals end, then well, wait a minute. There is at least one sample. So if it is equal to end, then it's not equal to begin, because begin is not equal to end. So if this is true, then we know that it was not true, and therefore well, we won't do this, but we will always do that, which is the same as what we did here. Then I can delete that. Well, while I'm at it anyway, in terms of making it compactor, let's remove these. Now this actually is normally an acceleration. So we know we have at least one sample, therefore back and front exist. And if the sample at the back is less than or equal W, then all samples are less. And that's exactly the point where this find would return sample end. But if this is not true for the last sample, aka back, then the opposite is true. So then the back W is larger than W, which would mean that we would stop here. And therefore we would return the last one. So if this is not true, then it will never be end. It will never be end because of that. Okay, remove this. And I suppose the same holds for this one. This filters out when we return begin. See, if the first one is already larger, then we do this, meaning that the first one will never be larger than W during this find, because then we would already have returned. Therefore, it will never return begin. So this is always the case, and I can remove that as well. It's true. Pretty sure that's true. Okay, so I can get a sample const pointer by calling that. I think I can now reset the history. And then we have to add both symbols again. Approximation add. Current is replacement. What? How does that make a difference? It should already be in the approximation. Well, I just reset it, so it is not in the approximation, so it is not a replacement. Otherwise, we disassert would fire. Let's just do a false. Probably the same reason why false was given there. Yeah. Now this was already in history. This two. They're both in history, so they cannot be equivalent per definition. Well, I mean, if everything works. So one would not replace the other, so they are different enough to actually make an approximation. I think you can be pretty sure that this one returns first sample, because it just did a reset. Reset history is calling approximation reset. So after this one, I changed the disconnected to some other result from approximation add, which is the same as wait, that's approximation add. It's not returning a result. It's not returning a result. It's not returning anything. Oopsies. Guess I have to call this as well then. Minute. Zult. First call. Should be set. Why? I'll remove it, but it's true. Just it. or in algorithm, and I don't have a skill. Yeah. No, I don't. I think I need a current to put. Just need approximation pointer, I guess. Get a skill from the approximation. One of these days I'm gonna open my keyboard, clean that A key. It worked. Now I'm curious. Go down a little bit, jump here, jump there, into it, jump there. You have a straight line through 5, but it should have combined the 5 with the nearest point here. Why am I not seeing that? Am I seeing it now? I don't think so. We just have a 5 and a 6. I think 6 is the result of a, I don't know, continuing or small step. Small step. So it kind of didn't work. I think the straight line, that I saw through 5 should already have been a cubic, using the nearest point here. Let's put a breakpoint at where I just worked. See what the hell goes wrong. So that was where I'm calling get nearest sample, which is there. GDP break run. So the last point 5 disconnected from the last approximation. And then we call nearest sample on the current scale, and I'm pretty sure that scale should contain and stupid samples is not printed nicely. Just get that. But okay, that says 6 samples. I can print them by hand, I guess. But it has 6 samples. That's hardly the number of samples that we have at all. So everything is in there, including those samples around. Oh, what is this? 12, right? It's probably 12. You can see that just the first one. 12. Now, I could do a step, but then we get into W and into current and really, I was there was a smarter way to do this. Could set a breakpoint, I guess. Maybe let's try that. So it's just breakpoint. Okay, so now samples back should be the one. And it's 15.7. What? Oh, it was added. Oh, right. Yeah, well, if it was added, then this is never, ever, ever, ever going to be true. And the nearest point is going to be itself. That's what's happening. Yeah. It's just going to find this one, which is itself. So then we have 2 points that are equal. So it's adding twice the same value. I can avoid that. I should look into it before I add it. That's not really possible, I guess. No, it's not possible because I get disconnected because maybe I should remove. Maybe I should remove it from the vector if it is disconnected, just so this works. Could do that, but. Just with those floating points, it's just so difficult to. So I was thinking too much to continue talking. It's difficult to be really sure that some value is equal to another value. Although maybe in this case it is, because it's just a copy of a double. I don't think that will ever change, right? If you have a double with a really nasty value and then you have copy that to another double, then they will be equal. Not more or less equal, but they will always be exactly equal. But that means you can't do this anymore. Yeah, I think I'm going to do the following. I'm going to pass the pointer to the sample. Which is kind of canonical in this way. I think we have only all the pointer to is I store them in the history, and for the rest I work with pointers. I don't make copies of samples. No, of course I do. Actually, I do. But or do I? I'm not sure now. I'm working so much with pointers, actually, which of course should never be invalidated, that it would be super dangerous to make a copy of a sample. Maybe I should just disallow that. So yeah, hopefully that won't break everything. So let's first try that. Please just compile. I am making a copy to the local extreme. Yeah, okay. I mean, it's actually not really a problem, I guess, making a copy. But it is not in this case. I could abuse the move constructor and then not actually move it, but then move a constructor into a copy constructor. But then I still have to use a standard move to make a copy. So I'm forced to think about it before I make a copy. It's kind of dirty coding, isn't it? But yeah, why not, you know? It's really dirty, but I don't think it's a bad idea here. So let's say dislike copying because we use pointers all the time. But if you know what you're doing, you can use the move constructor. And since these are just two doubles, I mean that the move constructor is the generated move constructor is just exactly the same as a copy constructor. So it's really abuses, but okay. Yes, so now it should still give me a compile error, hopefully. Because that was the whole objective. Yep. So here I'm making a copy and now it's warning me that I'm making a copy. And then I'm saying, yeah, but in this case it's okay. So I just use standard move. And then to make it extra dirty, I'm not changing this into an R value reference. I mean, if I would make it an R value reference, that doesn't change anything on this side. It's an L value reference anyway then, in this function. I would only make it an R value reference for the caller, which I'm not interested in. So this is the way I want to do it. Really dirty. Maybe I should add a comment because it is so dirty. Huh? Now I'm confused. Why would this still try to use copy constructor? To choose this. Maybe the default thing is not doing what I think. What was implemented? Oh wait, this default is yeah, I said default, and then the compilers are just going to do its thing, which is deleting it because the wait does not have a move constructor. I think maybe that's the reason. But W itself is in there as well. So yeah, if I try to implement it like this, then I guess we get that we will get it to complain. So you can just make a copy of these things. But yeah, the base class, okay, just call the copy constructor the base class, who cares? So normally for a move constructor I would have to use a standard move original, and then we would call the move constructor of weight. But maybe that doesn't exist. Actually, I expect it to be pilot generated. Yeah, I wouldn't really know why this thing does not have a move constructor, to be honest. But move and copy constructor are the same thing also, because it's just double. try it like this. Now I really wanted to call this move constructor there, otherwise I don't get it. Wow. No, I think that if you define a move constructor, then the copy constructor is deleted anyway. So what I can do is delete this. This thing should not have a copy constructor because we manually defined a move constructor. And now at least the compiler can't point to that line anymore, saying, you deleted it. Now it says it. Copy constructor is implicitly deleted because sample has a user-declared move constructor. Yes, indeed. What the fuck? I'm trying to move construct vertex sample here. Is this because this is not an R value reference? Is that the reason? Then the standard move did not do what I thought it did do. No, come on. Maybe because this is a const reference, that standard move just doesn't convert it. Maybe it's the constness of it. Wow. It seems that this I think that this cast here, normally I see this as a cast, is failing. I mean, normally, like I said, you would do this and then it won't be failing, but then I have to start moving sample to local extreme as well, which I really don't want. I just want to have a const reference, and I want to force this thing to call the move constructor here. And I can't do that with standard move. Okay, so what about static cast? If that doesn't work, a reinterpret cast, and okay, it gets more and more dirty. This might complain about casting away the constness, I think. So I have to do a, maybe I should do a const cast and then a standard move. Ah, yeah, now of course, yeah. Since this thing is const, you can't pass it as an R value reference to a move constructor, because that would invalidate the thing that you are moving, and that it's not allowed for a const reference. So I now expect that this either not to be allowed at all, or that it's not allowed because of the const. Casting away the const. Cannot cast L value of type const sample to R value reference. Types are not compatible. So that could be the const, or it could be that you're just not allowed to do that period. So we begin with const cast. Now I'm curious what the hell is allowed. So let's begin with the const cast, and I just have a non-const reference, and then I try to cast a reference to an R value reference. Please, now the const is not getting in the way. I think that worked. Yeah, I think it worked, and now it's double working because it's drawing my attention to the fact that I'm making another copy here by means of an assignment. But to make it less dirty, I think I can make, I think that now that should work if I just make a move here. Although maybe keeping the static cast is cleaner because I'm not really moving it, right? I'm just abusing the move constructor. What about no, I don't know. Let's use standard move. Who cares? Okay, so here I'm also making a copy. Yeah, but I mean, I'm making a copy of a temporary. So we're constructing a temporary and then assigning it. So that temporary is actually an R value reference. So I could make a move assignment. If I add a move assignment for a sample, then it will again work. It's basically the same trick. The same dirty trick, but then I don't even have to change the code. Where's SR defined? Wait a minute. SR and SL. Yeah, just the local here. To local. Very local. It's defined outside this scope, so I have to leave it like that. So we just reassign it every time. It should never take a pointer to SL then, or does that not matter? I don't think I am doing that. What am I doing with SL and SR? I am taking a pointer to it. Okay, well, that is okay, because the lifetime of this thing is very, very long. It's a cubic test. It's even a random. Anyway, I'm going to do the same thing. Yeah, I don't know, I'm just going to assign stuff. Might as well access W directly, I think. It's just a protected thing. It's protected, so I can access it here. Yeah, okay. So now I can change this by just passing a pointer to it, which I now call canonical because apparently they are. That means that get near a sample now uses a pointer to a sample instead of the value of the double. And it's only called from that one line, so I kind of know that it is the current sample. And then I'm going to rewrite this whole thing. I don't want to. I thought I put a lot of thought into it, but just let's start over. So I want to find. I know that it must be current must be added to the approximation in this case. I mean that turned out to be the case, so might as well assume that that is the case, and then deal with it when maybe ever that will not be the case anymore. But I doubt it. So I'm going to say current was already added to this scale. So we just find it. Well, this is more for an assert. So iter is unequal samples end. So I want to find it. Auto iter is samples find if, I guess. And then I have no idea what. Wait a minute. Find. Yes, I don't think so. Standard find if. Samples begin. Samples end. I bet. How does find if works? How does that work? Doesn't have an example of find if. Oh, here's an example of find if. Auto it standard find if begin end, comma is even. Where is even is a lambda. And the lambda returns true or false apparently. And I guess then it searches left to right or something, or begin to end, until it finds something where that is true. So we have some lambda, which, I know I've got it again. An int. What the hell is int here? It's probably the whatever is stored. Don't tell me that's passed by value. And let's assume that this store passes sample data const references. I'm going to call it data. So it should already be added, so the current should be inside samples. And we just find it. And then the nearest sample is then the one left or right of it. So not only it may not be empty, actually, it must be larger than, the size must be larger than 2. I think. Hey, Matrix. And Carlos and Jess, sorry, I missed you guys. So if the current is at the front, then we will just have to return the next one. So either +1 sample. And if either +1 equals end, which means that it is the one at the back, then of course it must be either it's now the either -1. And if otherwise either -1 and either +1 both exist, and then you just have to pick the one that is closest. So let's do the same as before. I'm just going to return no, let's not do that. Let's just test something and then return one or the other. -1 or either +1. Let's assign those things. My sample iterators are just pointers, so this is pretty cheap. So actually this iterator. I live in the Netherlands, Matrix. As if you couldn't hear that. It is, by the way, I think it's allowed to do -1 on begin, even though you cannot dereference it afterwards. But it's kind of the same as doing +1 on end, which I'm not sure is allowed actually. So maybe it's not allowed. In which case I would have to do it here. So then I know that it's not begin, so I definitely can subtract something. And this is definitely allowed because of that. Hello, David. Okay, so I want to have the one that is the closest to ether itself in terms of W value. Yeah, we're just going to compare it raw. So this is ether W minus ether left W is less than right ether W minus ether W. That's better. So last time we got just a straight line here, the tangent in 5. But now we actually have this cubic here. Fit through this point here, the nearest point, and 5. No, that's a parabola, sorry, this cubic here, the magenta one. Which is way more accurate, as you can see. Yay. Not thrown away 2 months of my life. We are more accurate. Okay, anyway, tuning 17.66. Actually, can I somewhere see what I just coded that's doing that? Not really, but well, no. Yeah. Adding it to the approximation. Yeah? So there's the other one is at 15. 15 is returned, and then we return disconnected. And then we call them here 2 times. So 12 was the one that is closest, which is definitely correct. And then we do a cubic fit through those 2 points. Yeah. Perfect. Good. So jump here. I guess jump here. 4th degree polynomial. Still a jump. Nah, that was already close enough. See, that's 18 is the right one. Oh, this is, wait a minute, jump to vertex plus small overshoot. Oh, the maximum is reached here already. So then what is going on? The maximum is reached for 17.98. I agree. That is close enough. And then what it is doing is returning 18 anyway. No. That's too slow. And even if this is not slow enough, it stays there. It just keeps trying to approach. Are we never going to leave her anymore or something? The maximum was already reached. That's the second time we reached the same maximum. Okay, we definitely found a bug here. So if I do top again, now we escape it. Yay, really? And we jump all the way to the other maximum. And now it's to the third. Yes! This code is not implemented. But, what the hell is happening there? Oh, this late matrix. Yeah, a lot of people from India are watching my streams. If we don't watch out, India will get a Dutch accent. I feel like eating something. Damn it. Shops are closed. Fridge is empty. That one still worked. Okay. Just making sure. Is it me or is the sound dropping away on the left channel? Shit, it's again. My headphones are broken again. I bought contact spray, and after I sprayed that into the plug of my headphones, It was fixed, and now it's back again. Put on some normal music, see if I can hear it in it as well. Yep, definitely. No, then you can write a review about this context spray, I guess. It worked for 1 month. Yeah, I think I'm gonna stop with the stream. Why the hell would it not? It's already close enough, man. Oh, I see. Yeah, this overshoot is very small. And I guess that what is going wrong is that afterwards we do not detect that that is a local extreme. We should get here again. Should get here again the next time then. I don't think it makes much sense to probe again, take a sample here on a minuscule distance. Just a waste of sampling. But you know, even this should work. So I'm going to look for why it doesn't. So after the jump, the small overshoot, returning 18 a little bit. Now we have enough samples. So we went from an overshoot, so that is, we did overshoot to the right, and then we plan to go back to the actual maximum, to the left. So this is towards the critical point. But now we did overshoot, so we're going to the left now. But okay, it's still towards the critical point. And yeah, as it should. It detects again that we are in the maximum. And now I have enough points. But it's returning 18 again. I think that the problem is that I should not return this value. We should immediately go for handling the local extreme. I'm pretty sure I had code that already does that. So maybe that's somewhere else than where we are now. Okay, so it's really just returning one sample too much, I think. Around the maximum. So I had code that handles a local extreme. And that is being called. I only have two places where that is called. So one of them is then the normal place, and the other one is the place where, well, what I meant. I think this is the place that, this is the normal place. So we come back and we see that it's a local extreme, and then we handle it. So then the other call, what's being done here, do not return a value that would replace the current sample. Yeah, that is the case. So I could do this, and that's the spot where we were just. But this is using negligible. Yeah, I don't think that this is not the place where it goes wrong now. So where's that then? Maybe it is actually. Could be that the handle approximation is trying to return this. And then we get here because we just detected the local extreme. It's just not the case that it is negligible. Yes, that is what's going on. So I need to set a breakpoint like, let's say here, 7.4. Which file? Algorithm, I guess. So annoying. And then I pressed C in the wrong window. So it's not negligible because one thousandth of the current step is yeah, it's not smaller. There's a 3.8 here and there's a 0.5 there, so it's not smaller, just not negligible. How to solve this? Yeah, I'm gonna quit. I have an idea, but I just don't. It's almost bedtime anyway. I think that taking a almost negligible step here makes no sense. So I'm gonna take a step equal to the scale. Get a point here, and then upon returning that, I just set the state to a new state. That just signifies this exact case. And then as soon as we enter the algorithm again with that state, it's just going to collect all the points and do the fourth degree polynomial fit and then jump to it. It's like literally treated as a delayed fourth degree polynomial fit. And that's again a lot of work, so tomorrow. I don't feel like losing with chess either, but let's do some puzzles or something. No. Lie chess. I should have typed it there, I guess. Yeah, good night, Matrix. Take or push? I'm pretty sure I saw this on before, but of course I forgot. Think push. Nope, it's stick. Cry. I haven't got a clue. Probably push or take, but what is the whole idea of this thing? Maybe push, he goes in front of it and then the rook here, which is defended by the bishop. So he takes my rook, and then I take his rook. Then he has to stop me from promoting. The rook must go here. But then maybe I can just attack the bishop, attack the knight, which then gives check or something, which I attack again, which then goes somewhere, maybe here. No, I can't go there. Well, all the way away then. And then the bishop protects the promotion square. I'm gonna push. So my idea was a rook here. Yeah, must take. It's no other option. Then of course I take back. Then of course the rook must go here. And then I have to play my bishop here, attacking the knight. The knight must move, and then I go here. And then I promote. You can never stop that. Can never stop that. Yeah. Yeah. Weak diagonal. Could put this bishop here and it's unstoppable. Maybe I should just take the pawn. I can't take back, that would be mate. No, wait a minute, this is nonsense. I'm cutting my knight double. I could put my rook here as well, actually. Takes the rook, I take your check, and then mate. And if he doesn't, then I take the rook, takes back, and mate. So he must defend something, like bishop here or something. Yeah, it's a sacrifice the queen. The thing is that these three are the covered, right? The knight is covering this one and this one. So you want to give a mate here. So if I take with the queen, then well, if he doesn't take my queen, then it's mate. So he must take. Then you can give check here. So the rook must go back, very forcing, and then you can make use of this weak diagonal. The bishop goes here, check. You cannot put anything. You can sacrifice the. Oh, wait a minute. You can sacrifice the bishop. So I take the bishop with check, and then he goes to the corner, and then I hope to give mate here. Dang. So take, check. Rook back, check. Sacrifice bishop. Yeah, that's not working. Oh, I have no clue. I think in a real game I would just develop this rook here or something. But you have to make use of the fact that the rooks are not connected. Just don't see how. Maybe go here anyway. Bishop here. Take the rook. Take the rook. Bishop gives check. Goes here. Yeah, doesn't do anything really. I'm not seeing something. Come on, man. This must be easy. I mean, it must be such that if you see the move, then you see the move. Then you know that that's the move. Why am I missing it then? I think it's either the queen sack or the rook goes here. So the queen sack really doesn't work, then I'm going to put the rook there. See what happens. So I take here, well, rook must take, clear. And then this move, check. So I must go back. And then the only thing I have is check here. And it sacrifices the bishop. And then he must go there. And then what do I have? Nothing. Nothing. This rook is pinned, so I could take here. Yeah, the bishop is not. I did already take it, sorry, I took it. My bishop is here, so he goes in the corner, then I give check. And then, I don't know, I could go there, for example. Can give check here. He has to go back. Doesn't help one bit. I don't know. I'm gonna try the rook, but it's... I don't see that either. I think it's wrong. Nope, it's wrong. This one. Fuck, it is correct. How? I just looked at it. Well, I thought this, okay? It's still good. And then I thought this. And that's, oh, that's not good. Okay. Oh, easy, easy. Oh, I just missed that. So stupid. Yeah, I missed that move. I only saw this check here. Well, I saw the check there, but not in combination with this, well, combination. Oh, right. Yeah. Damn, man. So close. Yeah, I only looked at taking here. I must take, otherwise it's mate. Check, again, it's the only move. I only looked at this now, for some reason. But then you can do that. And I have nothing, because the rooks just defend each other. So you want to give check, but not over this diagonal, which gives him tempo with a bishop and then connecting the rooks. But yeah, now I can give check here. That wins. Very good. Does it win if I take here? Take the dangerous pawn, take back, fork, win the rook back. Then I have a pawn more, that's something. And then maybe I can just promote, because how is he going to stop that with the one rook and the king all the way here? Must work, huh? Yeah, that must work. I'm just going to do it. It's not good. How? Okay, then it's just promoting. No, wait, it's text me. Text this. How the F, man? Defend the knight. Nope. This can't be it. It just takes a knight. No. Bit vague. Oh, now you cover this square. Yeah. Yeah. Very true. That wins quality. You know, you promote without being able to stop it. So this idea I saw, but that does not work for some reason if you just take here. Why not? Oh, because he doesn't take it. Right, yeah. This is kind of stupid. Yeah, I just gave away a knight. I blindly thought, well, if I take, he's going to take my rook. And indeed, that wins. So I was right. I just was so stupid to assume that he was going to take my rook. Yeah, take my rook. And then, yeah, of course he's going to do that. No, of course he's not. Yeah, this indeed wins. So at least I saw that then. The problem with this move is he's not going to take my rook. He's just going to take that and be a whole rook up. Well, rook for 2 pawns, 3 pawns. No, it's a draw then. See, if now black says, yeah, wait a minute, I wanted to give this rook, so I could get rid of one rook, so we could try this. And now it's not winning because one of the pawns is gone and then the other pawn is also gone. Yeah, you just give, yeah. The rook collects 2 pawns and then gives itself on the last pawn. Guess you can just take you. Take you. Oh, I dropped it. Mouse slip. Okay, bedtime. Good night.